Session we have studied about some basic block diagram of op-amp, its internal structure, and we have seen its pin diagram also. We have seen some basic parameters of op-amp like input offset voltage, input offset current, input bias current, differential input resistance, right, and input capacitance. We have also seen the packaging, different packaging schemes of op-amp. So today we are going further with some more parameters, some more important parameters of op-amp. So the next parameter, it is called offset voltage. Okay, input voltage range. The next parameter is input voltage range. Right. So input of voltage range, it is the maximum value of voltage you can apply between the terminals of the op-amp, right, in common mode. Right, now what is common mode? Right, okay, first let me just write the definition and then we will learn about it. So when we can say when same voltage is applied to both the terminals op-amp, it is said be in common mode. Common mode, common mode voltage, right? And we can also call it V yes, we can also call it VCM. In suffix, we can write it as CM, common mode voltage. Okay. So what is the value, maximum value which we can provide at the input of the op-amp? It is known as input voltage range. So if I'm drawing the diagram of common mode voltage, then it will look something like this. So these two are the input terminals of the op-amp and this one is the output terminal of the op-amp. When we are going to connect, when we are going to short out both the terminals, here the upper one is, let's say, one is non-inverting and other is inverting, and if both the terminals are shorted and we are providing some voltage over here, right, this voltage is known as common mode voltage, right, and the maximum value of the common mode voltage which can be provided at the input terminals is known as input voltage range, right. So if we are going to consider about 741, right, for IC 741, so this value for 741, this value can be plus or minus, it may start from plus 15 to minus 15 volt maximum, right. So it is the maximum common mode value. Okay, sorry, it is 13, huh? Not 15. This value is 13 because 15 is for 714. For 714, this value will be 15. Okay, so is it clear? Input voltage range, it is the maximum voltage which can be applied between the terminals of the inputs of the op-amp. Fine. The next term, it is very important parameter which is known as common mode rejection ratio. Right, it is common mode rejection ratio. You can also call it CMRR. Right, it is also called CMRR. So CMRR is given as, you can say, differential gain divided by, this is your differential gain Okay, I'm just changing. It is very small. Okay, so differential gain divided by common mode gain. Right. So for common mode gain, we'll call it A suffix Cm. Right. Where AD is the differential gain. AD is differential gain. You mean by differential gain? When the two inputs are not equal. When two inputs are not equal, at that time whatever gain we will get when two inputs of op amp are not equal. At that time, voltage gain, differential voltage gain. Okay. So we are providing different voltages at the both the input terminals, non-inverting and inverting. And we know that when we have provided different input voltages, the overall voltage at the input is called to be inverting minus non-inverting voltage, right? So difference between the two voltages, right? And that at that time your V in will be the difference of the two inputs, and the gain at that time is known as differential voltage gain, right? And what about the common mode? Okay, can anybody tell me what will be the common mode gain? When two inputs are shorted, or you can say um, are given with same voltage, right? At that time you can say it is working in the common mode. At that time voltage is common mode gain. Okay, at that time voltage nahi gain. Same way here also I will have to just change. It is not the voltage, it is the actually gain. Okay. So it is known as common mode gain. The value of common mode gain, you can say what will be the equation for common mode gain. Okay, differential gain is provided in every datasheet of the op amp. Differential gain is always provided in the datasheet of every type of op amp, right? While common mode gain you can measure yourself, right? So basically you can say it is the um, output voltage. It is the output voltage when okay. It is the output voltage when input is in common mode divided by what you say? Divided by what? Divided by common mode input voltage VCM, right? Okay. And for 741 this value, okay, and in most of the cases we know that gain is written in decibel, right? So CMRR is also considered in decibel, and for 741 this value is to be 90 dB. For 741 op amp CMRR is equal equals to near about 90 dB. Okay, 90 decibels. So this is the next parameter, which is very important one. Then comes supply voltage rejection ratio. Right? Then comes supply voltage rejection, and sometimes it is also known as, we will call it SVRR. Sometimes it is also known as power supply rejection ratio, as like PSRR, power supply rejection ratio, PSRR. Right? It is the another name of the same. Right? So let's first define this thing. It is the change in input offset voltage, due to change in supply voltage. What is it called? The change in input offset voltage due to the change in supply voltage. Now we know that what is the input offset voltage, right? So input offset voltage is something, we know that this is a pin number 3, inverting is pin number 3, non-inverting is pin number 2, and here at 3 and at 7, at pin number 3, 3 and 2, and pin number 7 and 4, right? So pin number 7 is given with plus VCC supply, and pin number 4 is given by the minus VEE supply, right? So when your input is not given, right, that means the pins 3 and 2 are open, we have not provided any type of input, right? At that time there will be some kind of uh, offset voltage between the pin number 2 and 3, right? Though we have not provided any type of input, but then after, due to the internal circuitry, there will exist some potential difference between pin number 2 and 3, right? And that voltage is known as input offset voltage, right? This input offset voltage can also be varied if we are changing the values of VCC and VEE, right? So if these values are varied, at that time these values of input offset voltage will also change, right? So this change is known as the change in input offset voltage due to the change in power supply is known as supply voltage rejection ratio, SVRR. Okay, so we can write this something like this: SVRR is equals to the change in input offset voltage. So we'll write delta VIO divided by delta V. So delta V is your supply voltage, delta VIO is your input offset voltage, right? And for 741 IC, this value is near about, you can say, 150 microvolt per volt. 150 microvolt per volt. What does it mean? That when we are changing supply voltage by 1 volt, right, when we change the supply voltage by 1 volt, at that time input offset voltage will be changed by 150 microvolt. So the unit will be microvolt per volt. The next definition is known as the large signal voltage gain. So it is your actual voltage gain, you can also call it actual voltage gain, which is a large signal voltage gain, and this to be, you can say, output voltage divided by differential mode input voltage. Okay, differential mode input voltage. So just differential input mode मतलब when we have provided different input to inverting and non-inverting terminal, right? And how can you write it? This can be just written as A. You can also call it differential gain AD, right? So A is equals to V0 divided by VID. Okay. Output voltage swing. The next terminology is output voltage swing. Right? It gives the values of positive and negative saturation of the op-amp. Right? So you can say basically it is the saturated values. Right? So you can just write it as gives values of and negative saturation voltages of the op-amp. Right? So now what do you mean by saturation voltages? Do you know what is the saturation voltage? Any idea?
Ma'am, can you please repeat?
I want to just ask that what is the saturation voltage? You have studied in transistor. In transistor, if you remember that when we are going to give any kind of input, whatever the gain of the transistor may be, but your output will not go beyond some output limits. Right? If you remember, this limit was VCC. Right? In transistor, in the case of transistor, this values was to VCC. Right? So your output voltage cannot go beyond your supply voltage. Right?
Ma'am,
Always.
voltage between collector and emitter.
Yes, right. So it was VCE, that was VCE, right? So VCE, which was your output voltage in terms of transistor. VCE was output voltage in terms of your transistor, right? But this output voltage VCE cannot exceed VCC, right? It cannot exceed the supply voltage, right? Gain ગમે એટલો હોય, whatever the gain may be of the transistor, your output will not go beyond VCC. If your output is going beyond VCC, if you remember, you have drawn some diagrams, something like it was clipped off in saturation region, right? The positive half cycle was clipped off, right? And in negative side, in the cutoff region, when your output goes in the cutoff region, your negative half cycle was clipped off, right? The basic thing what I want to just tell you is your output can never exceed your input voltage, right? अगर ऐसा हो गया, then you can say your transistor or your op amp is generating the power, and it is not the case, right? If I am providing plus 15 volt as VCC supply, right, and I am providing 1 volt, and if the gain of the op amp is 100, right, so basically my output should be 100 volt. Basically my output should be 100 volt, right? If input is plus or minus sinusoidal wave plus or minus 1 volt, and my supply voltage is 15 volt, and the gain of the op amp is 15, so theoretically what should happen, that my output should be gain multiplied by input voltage. So gain is 100, input voltage is plus or minus 1 swing of sine wave, right? So my output should be plus or minus 100, right? So is it possible that we are providing only 15 volt to the supply and we are getting output at 100 volts? It is not possible, right? It is possible only in the power generating devices, and op amp is not the power generating device, right? So for every amplifier, when your input exceeds your supply voltage, your output will be clipped off. So the maximum value of your output will always stuck at your supply voltage, right? જેટલો તમારો CVCC હશે ત્યાં તમારું output છે stuck થઈ જશે. So it is also known as output voltage swing. It is also known as output voltage swing. It is the maximum values of the output which can be attained by the op-amp. Is it clear? Let's take one
Yes,
more
ma'am.
example. Okay. Do you need the example? One more example? Or it is okay?
Ma'am, one example.
Okay. So, for example, let's say we do have a sinusoidal input, right? And the differential sinusoidal input is there. We are assuming that this is the differential input, right? And this value is known to be, let's say, 1 volt, right? Here it is plus 1, and on the below side, for example, this value is minus 1, right? This is your time signal, right? And let's say if the gain, if the differential gain is 50 volt, for example, 50 volt, right? Then what should be our output? Theoretically, your output should be 50 times your input voltage, right?
Yes, sir.
So theoretically, it will be 50 and minus 50, right? But as the supply voltage restriction for 741, it is 13 volt, as I have told you, right? It is the maximum input voltage range which can be provided to the input of the op-amp, right? So the maximum value what you can provide is, let's say, 13 volt, right? So here uh, your supply voltage is, let's say, plus 13, and here it is minus 13, right? So in this case your output will be blocked at 13 volt, right? This value will be 13 volt, right? And the portion above it will be clipped off. You will not get the output which is greater than this, right? So you have studied about the clipper circuit. Same way here also at minus 13 your output will be clipped off, right? So your output, your actually what you are getting is something like this, only this much. So I think it is clear now. Okay. The next parameter is output resistance. Okay, so what should be the value of output resistance for amplifier? Any idea? Anybody? What should be the output resistance? Always for any type of amplifier, our output resistance should be less and our input resistance should be highest, right? So practically this value should be less, or you can say minimum, right? So when this value is less or when this value is minimum, you can say you will get the maximum output, and your input resistance should be there, right? So output resistance should be ideally it should be 0. Ideally output resistance should be 0, and ideally your input resistance should be infinite, but it is not the case. It may vary. You can say this values are in terms of some ohms or some kilo ohms, and our input resistance will be in terms of mega ohms, right? When we are calling it infinite resistance, it will be in terms of mega ohms. Okay, so output resistance is the equivalent resistance, you can say, it is the equivalent resistance that can be measured output and ground, right? And basically for 741 IC, this value is near about 75 ohms. So sometimes these values are not provided at that time, you can take these values. The next parameter is output short circuit current. So basically we never short our output, right? But then after, if something happens and our output is shorted accidentally, right, to the ground, then protection must be provided, right? Otherwise your appliance which is connected to the op amp will get burn off, right? So what is the maximum current which can be flown when your output is shorted, right? When accidentally your output is shorted to ground, what is the maximum value of current which is valid for the op amp without affecting your output, right? It is known as output short circuit current. Okay, so you can call it like, if okay, if output ground is it accidentally, then maximum value of current which will not affect your op amp is known as short circuit current. Okay, and for 741 or IC 741, this value you can say it is near about 25 milliampere. You can also call it ISC, I suffix as C. Okay. Then comes supply current. So we know what is the supply current. And we can also call it IS. Right, so you can say it is the current drawn by op amp from power supply. I'm telling about power supply, huh? Not the input, right? And for 741, this value is to be 2 point near about 2.8 milliampere. The next term which is important is known as power consumption. We know all this thing, power consumption. We can also call it PC. So you can say this is the amount of the quiescent power that must be consumed by the op amp in order to operate properly. Right. Now what if you remember, quiescent point of the op amp is the operating point of the op amp at which your op amp is working, right? So quiescent point is nothing but your operating point at which value of value of voltage and what value of current your op amp is working, right? That value of voltage and current is known as your quiescent point, output voltage and output current, right? So that output voltage and that output current related whatever the power consumption is there is known as power consumption of the op amp. So we will define it as the amount of, I'm not writing quiescent, I'm just writing operating power that will be consumed by the op-amp in order to operate properly, right? And for 741, this value is near about 85 milliwatt. Okay. Okay, so you can also see that power consumption will vary, right? Power consumption will vary as per your input, as per the input provided at the pin number 2 and pin number 3, right? But when you have not provided any type of input, let's say V in is 0, right? At that time also there must be some power consumption due to the voltages, right? Due to the supply voltage VCC and VEE. તો એના લીધે જે કંઈ power consumption છે that will be known as the power consumption when V in is equals to 0. So I think it is clear all these parameters. And one more, the last one. Okay, two is left, are left. The one is slew rate. It is very important parameter, slew rate. Right, slew rate is also written as SR. Right, so it is the maximum rate of change of output voltage, maximum rate of change of output voltage per unit change in time, right? So if you remember that this will be something like our output, right? So for example, this is our output, right? So what is the change of output voltage per unit time, right? If we are considering that much of the 1 unit, right? If we are considering this time is to be 1 unit, then in this 1 unit of time, what is the change in the output voltage is known as slew rate, right? The maximum rate of change of output voltage per unit change in time is known as slew rate, right? So slew rate is defined as SR is equals to dV0 divided by dt. So what will be the unit of slew rate? What will be the unit of slew rate? Any idea? From this only? Obviously, this value will be volt per time, right? But as this time is in terms of microseconds, we will call it volt per microsecond. The unit is to be volt per microsecond. And for 741, for 741 IC, this value is near about 0.5 volt per microsecond. Per microsecond. Okay, and the last one is gain bandwidth product. Right? You can also call it BW. A into bandwidth. So it is the bandwidth of the op-amp when voltage gain is 1. Also call it, it is the bandwidth of the op-amp when voltage gain is 1. Yes. So I think all these parameters are clear in your mind now. Yes or no?